My name is Malcolm Foort. I work for a company called Zeus. As he said there, I'm their innovation director. Now, my history as a person, my career has taken me mainly through an IT path. I worked for software companies and solution companies for basically all of my career. Moved into Zeus and into the world of BIM about 4 years ago, as Shannon said. It's a bit funny being here. I've been in a few design, coordination review meetings. This is like the world's biggest one, the way everyone's looking, which is an interesting experience. So look, I'm the innovation director, which out of all the job titles I've ever held is by far the best one. My job at Zeus is to deliver software outcomes. It's to look at our clients' requirements with BIM and the technologies available, and deliver on those requirements and give those outcomes, using innovation and using new and interesting ways to serve on those outcomes. Today I'm going to talk to you about some of our experiences and learnings in taking BIM into FM. I'm going to use some real-world examples of some of the projects that we've worked on, and touch on some of the key issues and the key challenges and how we solve those challenges, and what the implications are on the BIM industry as a whole for moving into the FM space. Of course, it's all a very important sort of target to have. When you actually build a building, people talk about the construction value of a building. There's a new $2 billion hospital, just to use a number at random. But of course, that $2 billion is the construction price, and constructions are often just about 20% of the overall cost of running a building. So, in total, we're looking at, billions and billions of dollars over the life of that building being spent, up to $10 billion to actually, as the whole cost. So concentrating on BIM and FM and bringing about efficiencies by the use of this technology can bring about real significant dividends over and above what's traditionally delivered in construction and design. So what I'll do at the end as well is just summarize some of those learnings again, and summarize how we see where the industry focus needs to be to start to be delivering more into that FM phase. Okay, so just a quick introduction as to who is Zeus. We're an Australian-based software company, as I said. We have a marketing team who have instructed me to give you this definition of who we are. We are a full asset lifecycle solution, blending 3D BIM capability, mobility and information management to reduce costs, deliver greater control, and enable better decisions. Which is, it's a great definition, but what does it really mean? It means, taking BIM and using it in the best way possible, in innovative new ways, to enable people who are operating buildings, asset owners, to make better decisions. Now, inevitably, that often means giving them access to information, pulling information in from various places, and making it available as and when people need it. And that's really what we're trying to achieve. We've got a growing development team in Brisbane and Melbourne, and offices in Auckland and Bangkok. So as you can see from that list, we pick all the fun places to put our offices. As I said, we've always had to focus on leveraging BIM in FM. That's always what we've been about. So since our inception 4 years ago, we spotted an opportunity in the market. We spotted a potential for building information modeling to deliver a new sort of paradigm in the way that you operate buildings. And that's always been our focus. And it's been a very interesting journey, in that 4 years, especially considering, we came in as software people looking at how we could solve problems and provide outcomes. And in doing that, meeting industry representatives from asset owners right through to designers, modelers, engineers, architects, and so on, and pulling all of that together into what we could deliver has been a fascinating journey. So as we have evolved, what we've started to realize, and what you can see up here is our solution set that we provide to our clients. What we started to realize was, BIM and where its place was, as we could see it in the operations of a building, what it could actually deliver. And that evolution really showed it was the interaction of BIM with things like a mobile workforce, everyday FM, how to give people access to information. And it moved through asset management, energy management, lifecycle management, space management, all sorts of different facets of the building. And what we try to do is build up a solution set that pulls a lot of those key requirements into a single sort of solution that spans the full life cycle of the building. You know, a very simple example, taking digital O&M. Okay, now O&M, great phase in construction where a lot of really, really useful information is generated that when you come to operating the building, you know, having access to that information is really, really beneficial. And what we could see with BIM is it delivered a really superior contextual way to deliver that information. You know, imagine walking around a model, make the ceiling disappear, see an air handling unit or a VAV or whatever it is, clicking on that and then getting access to the operations and maintenance information, the user manual, the warranty, or if it's a piece of pipe work, you know, clicking on it, seeing what system it's in, where's the shutdown valve, and that kind of information. That's what we sought to try and do, to deliver contextual O&M. So we have a module that's designed specifically to collect that information and link it to the 3D model and link it to an asset register and make it usable. Now, sometimes, you know, our technologies, we do surface the 3D model to our clients and let the users walk around a model, make things disappear, click on things. But sometimes deliberately we don't. And things like the O&M module is purely web-based. But it's the sort of smarts behind when we're capturing that information, what we then need to link it to, which really sort of sets us apart with other sort of O&M collection solutions. So today I'm going to focus on some of the defining projects that we've been involved in. So the projects that have sort of thrown up the challenges of what does BIM in FM really look like, and try to summarize to you how we looked at those challenges and how we solved them, and then what the implications are for the BIM industry as a whole. So yeah, look, I think the final thing to say on this, without going into each of these modules, is what we're really trying to do across that life cycle is smooth the flow of information, so that when you're in the depths of operating a piece of machinery, or you've got some facilities management work to do to it, what information do you need access to make that as efficient as possible? And the information might come from various sources. It might come from O&M. It might be that there were defects raised during defects liability, and you want to see that against the backdrop of the work orders and the condition assessments that have been done. Combining all that information from different places and delivering it in a single platform. That's what we're talking about really with the full asset lifecycle story. Okay, so we've got a number of customers that we've worked with. You know, we've got 130 clients. We've got something like $50 billion worth of assets being used and run using our software. We've been involved in some pretty high profile and some less high profile, I guess, BIM projects. I guess the biggest one would be the New Royal Adelaide Hospital, which I will sort of talk about today. There's also been other interesting projects, Pyrmont Bridge in the infrastructure world, you know, obviously a bridge that's very old, that had a sort of BIM model retrofitted, and we've helped out. Again, I'll show you some of that today. Flinders University, who out of all of the universities we found as most innovative and wanting to drive change. We've done a lot of work with those that's ongoing. PA Hospital, again, an interesting one because it was taking the existing built environment and delivering to them outcomes. So I'll touch on that one as well and how we sort of tackled that thorny issue of, well, I've got a portfolio of 10 buildings and I've just had this beautiful building built and here's a full 3D BIM model, but how can I use your system with these 9 others that have you know, been around for 10, 20, 30 years? How do we bring all of that information into one place? We work just down the road at the Shrine of Remembrance. We work for Energy Australia in the power sector. And Spotless as well on several PPP projects in the education space. So, why use BIM models in FM? Okay, so look, this slide will start to rattle off when I press the button. Some of the obvious benefits of an ultra-accurate 3D model, and if you have the ability to make it usable, how that can bring benefits into the operations of a building. You know, imagine finding, you've got water dripping through the ceiling, you make the ceiling disappear, you've got a pipe, you click on the pipe, you understand which system it's in, where's the shut-off valve. You're going to make your whole life a lot more efficient and effective. But really, the ones I want to sort of focus on just briefly here are these last two points here: the source of information, and the accurate schedule of quantities. What that's starting to deal with was something that Alistair touched on in his presentation about that level of information that's held in models, the non-graphical data that's contained. So, we see the industry has been very focused on the use of BIM through design and construction and the 3D components. But what we found in the projects we've worked on is, as a source of information that's purely non-graphical, there's been a lot of inconsistency in what has been delivered. An interesting little tidbit, if you like, on the projects that we've worked on. Out of all the different disciplines that we deal with models, out of all of them, the mechanical models, for some reason, always seem to be the best. So I don't know how many mechanical guys we've got in the audience, but a little pat on the back for yourselves for delivering that consistent information sort of voluntarily, if you like. So yes, that non-graphical information is going to be a theme that I'll sort of talk about today. And as I said, as Alistair said in his presentation on the Brisbane development, it was very heartening to see the methodical approach that they're applying on that project, because we've worked on a few projects, and the kind of information that we need in a model and consistency has often been very, very lacking, which has resulted in pioneering projects. We've had to do a lot of that work ourselves. And I'll sort of try and describe what that involves as we move through the presentation. Now, this final point here, central hub to access building and asset information, this final point is one that we see as the most important for things, for 3D BIM models. Of course, you've got a model even before the thing's being built, okay? It's coming through the design stage, coming through construction, and going into operations. A BIM model is something that's prevalent throughout all of those phases. So to use it as this central hub to access the building and the information about that building is an absolutely natural thing to do. It's visually a compelling way to bring information out, to access information, and it's always there. So developing a system that can handle iterations of models and link that information and make it usable is very much where our focus has been through our evolution. So, achieving BIM in FM. What I'll do now is I'll talk about some of the projects we've worked on. So, New Royal Adelaide Hospital, I suspect many people in this audience are pretty familiar with that project. I dare say a few of you have actually worked on it based on the size and scale. Now, look, it's a project of superlatives, okay? There's, by some measures, the world's third most expensive building, which is quite daunting. Certainly the world's most expensive hospital. Now, of course, with physical handover of something that size, with it being a full BIM project, the actual digital handover, the actual amount of information that came to us when the building was finished, was also vast and unprecedented. And, talking to Spotless, who was our end client, the facility managers of that facility, their challenge was quite simple and said in complete ignorance of the sort of technical challenge. The challenge was, look, you got all of these models, 731 of them. You've got 46,000 operations and gigabytes and gigabytes of operations and maintenance information. And then we're going to be storing, operational information in the system. I want all of that available on a mobile device, a common or garden iPad or an Android device, so that I've got instant access to my information. And all of this against a backdrop of pretty strict KPIs that the Spotless facilities management team were up against. Now, it goes without saying that as a challenge, and the physical sizes of the files and so forth was pretty hard. It was a very, very steep challenge, and it caused us to have to go back to the drawing board in a number of ways to actually tackle this challenge. But it really boiled down, the success of that project really boiled down to two key things that enabled us to deliver. One is technology, using new technology, and two is the way that the BIM models were actually developed. Now, interestingly, that was something that to a large extent was outside of our control. So luckily for us, there was a BIM management team, which I'll talk about, who imposed some rules. And I'll sort of show you where the importance of that came, as we move through the next slide. So first up, the technology. What are we going to do to deliver these things on a mobile device? And there's already been a bit of mention, I think, before in something called Unity. Again, the solution for us was Unity, using gaming technology to deliver those models on a mobile device. What we want to do is make the models usable. It's never going to be that an FM guy is going to use something like Navisworks or God forbid, Revit to try and get access to information. So we had to take those models and in some way bring them onto a mobile device and make it as usable as possible. And of course, as all of our kids will attest, the gaming industry has already done that for us. So it's a very natural progression for us to use that kind of technology and the compression and so forth to actually present models. Now, what we also do is we made very smart use of the mobile device's memory. So, the hospital got chopped up into sectors and levels. And we were able to bring about a situation where you could walk through a model and go through a wall. And as you went across these sectors and levels, we would dump models out of memory and load models up in memory even before the user would notice. But there was a lot of things that we had to do that enabled us to, even with Unity, to present that information, to actually make that workable. We also had to design our own DBMS. So, of course, smart devices, mobile devices, and what have you, they've all got databases underneath powering the data that you stored. But unfortunately, we couldn't find one that actually could scale to what we needed to deliver with NRAR, so we wrote our own. And then finally, we worked with Spotless to categorize the huge amount of information and documentation that came with the project so that we only downloaded those critical things, and then we offered a sort of download on demand kind of approach when particular documents are required when you're out in the field. So the other aspect, though, which is perhaps more relevant to you guys, is the models themselves. Okay, so luckily for us, Hansen, Young and Leighton's contractors, who were the head contractor on that particular PPP, had a BIM team led by a gentleman called Chris Penn, who some of you may have heard of, may have known. He's quite active in the Building Smart organization, and is obviously a vocal sort of proponent of BIM. And what Chris did for us, which is very fortunate because we weren't actually involved in that process, was he very clearly defined the non-graphical information elements that he wanted to put into that model against all of the assets and elements that we required information about. He was very clear about what information to put in, how to describe those elements, excuse me, and then the most important thing is he enforced it. And again, Alistair touched on that before. Very important, once you specified these things, to actually enforce them, because the immediate need to enforce that information won't come through building, design and construction. It's actually when we deliver into operations. But as Alistair was alluding to there, having those different drops at different times through the project and making sure that information is full, complete, correct, and consistent is very important. So on a model, on a building that size, having that consistency inherent in the model, and in particular how Chris and his team made the modeling teams in a coordinated fashion identify assets in a meaningful and unique way, and he identified them not only as a unique identifier, but encoded within that information. They also said, what is something? What's its functional purpose? Is it an air handling unit? Is it a chiller? And also the location of those assets. And he did all of that, and he thoroughly enforced it. And without that, we wouldn't have been able to have put together the processes, the automation, to take that number of models and reconfigure them for use in FM, which obviously we relied on technology and automation to do, but it needed that sort of consistency. So we'll be forever in his debt for taking that, because on a project of that size and scale, there's no sort of solution on earth that could make use of that in the way that we've been able to. And that is, going to be an underlying theme in what I'll talk to you about this afternoon. That need for consistency, in particular with the level of information, the non-graphical information in those models. So another project we've been involved with is the Pyrmont Bridge, which you may be familiar with from Sydney, if you've been in Sydney around the Darling Harbour precinct. So it's an old heritage-listed bridge built in the 1900s. No, 1800s. What am I talking about? Built in the 1800s. It's a timber bridge made from Tasmanian oak, spanning the area there where the big 3D cinema is, the IMAX, and the museum and so forth. We were introduced to the project by a gentleman called John Mitchell, again from Building Smart. What he wanted us to do was demonstrate how our technology could take the IFC file that GHD had created and facilitate, allow them to enter information against that model in a nice, structured and easy way, because they have an annual inspection of that bridge. Every year, two guys come out from New South Wales RMS, and they structurally assess every single component of that bridge. And there's about some 8,000 that they look at. Now, I don't know about you, I'm not very good with names, but these two guys are brilliant. They're both called Steve, which made it very easy for me. The two Steves would come and they'd inspect every one of those elements. And in the old days, they would do it on a clipboard, and they'd have digital camera, and they'd come in and do the inspection. It would take about 30 to 40 days. Then they'd go back and they'd write this huge report. They'd literally, in some cases, they're coloring in trusses with the different colors that represented the different conditions of the elements. The whole process took 70 odd days from start to finish to actually deliver that information. So they had this 3D model, and they said, look, how can you help? So what we were able to do was bring that IFC model into our platform, and then present a way of entering mass data against that 3D model. But in this actual case, we didn't actually use the 3D model to drive that sort of data entry. We developed an app that was capable of allowing the two Steves to get into the bridge and via a hierarchy say, right, I'm in span 3 today, I'm in truss 2, and I'm looking at vertical AA, and now I'm looking at the structural diagonal AB and the shoe and so forth. And they were able to do that in the app, and then enter the condition assessment, enter the paint condition, take photographs. Since then, we've expanded the app and the data we can collect to sort of specify whether elements are original or they've been sort of retrofitted and so forth. So we can use their data collection for all sorts of different purposes. But they did all of that in this app. Now, this app, when it's connected, would automatically sync that information back into our cloud environment, and automatically it would be linked to the 3D model. And what you can sort of see here is this visual is something that they use to aid and assist in the way that they then subsequently work package information. And they actually make, for people to come in and sort of fix things. And they actually make the model available via our platform to potential tenderers so that they can move around the bridge and understand its structure and do a more qualified response to tender requirements. So what you can see here is things in red are condition 4, things in, it's sort of orange color, but it looks yellow here. Things in yellow are in condition 3, and condition 2 and condition 1, which is the best conditions, are just sort of ghosted out in white. But it gives them a whole new way of visualizing that information. So what we've been able to do with the two Steves now is take a 70-day process and actually reduce it to the pure 19 days that they are on site. They enter all of the data at source. It comes up into our environment, and literally as they're doing the work, you can color the model in to show progress or to show the actual results of what they've done, which has then enabled them to take this much more holistic approach in how they maintain the bridge. They can spot cause and effect, so up at the top there where there's a hole in the deck surface in span 3, they could actually see a cone of corrosion that came out where the water was leaking through onto the elements below, and better convey that information to management and better package that information up. So look, it was for us a groundbreaking project, but what it really emphasized was, BIM is that great anchor for information, but sometimes it's not always the best way of putting information into the system. Again with the O&M, present it in a web-based browser, allow people to upload documents and link them. Don't necessarily show them the 3D model, but the end result, the contextual O&M is what we're driving at. So another project we were involved with is Princess Alexandra Hospital. So anyone who's Queensland based will probably know this is the main hospital just outside of Brisbane city centre. Been around for a number of decades. They had some very basic 3D models that they put together themselves, and then they had areas of the hospital that were quite detailed. So they had different organizations, engineers and so forth, come into the building and do fire audits and things like that. So they'd employed BIM on quite specific tasks, but obviously overall they really didn't have a very detailed BIM model across the entire building. Now they called us in within their FM side, and they had a number of objectives they wanted to achieve. There was a number of operational efficiencies we could do with just turning them into a sort of digital environment. But what they wanted us to do was bring the models in, give them a pathway into BIM, and then integrate with their SAP system, which had records of some 300,000 assets. Okay, now obviously those 300,000 assets, have been built up through SAP through a number of years, and they had some basic BIM models. But the question was, well, how do I have a system that can handle all of those different assets, and then a BIM model that's perhaps only got 500 when you start, and then maybe we'll do a fire audit on level 2 and we'll have 600, and then we'll do some other audit on level 8 and we've got 800. Slowly they'll make their way into a more BIM-enabled environment, but it's a process that just comes through the natural life of the building. What we had to deal with was a BIM model that basically didn't have everything in it, so how do we approach that? And the solution really lay in underpinning the way our software worked with an asset register. And that asset register became a superset of what was in the model. So the BIM model, again, is great at modeling certain elements and fixed equipment and pipe and ducts and so forth. But for things like a hospital, you've got hundreds of thousands of assets that are mobile and moving around the building. Now, an asset owner wants all of the information in a single place. He wants to search for assets regardless of whether they're fixed or mobile or whatever, and bring back the information about those assets. So for us, developing this asset register that could handle everything in SAP, 300,000 assets, and link that into the model in a way that when they increase the detail in that model, it would inherit those linkages in the asset register, was really what drove this project and gave us the success that we had. So what we did on the modeling side was we developed a concept we called a level 1 model, a Zeus level 1 model, as an example. Now what that was that it would basically take the 2D floor plans of the hospital. And thankfully for us, again, a little break we got was PA Hospitals is quite unique in that, well, I don't know if it's unique, but the floor plates and the walls sort of extend throughout the whole building. So as you move up the levels, they're all sort of laid out in exactly the same way as the floors below and the floors above, which made things quite easy converting that model. But basically, we designed this concept of a level 1 model. So taking the 2D floor plans, extruding them into 3D, but not modeling all of the services and the pipe work and the duct work that brings about the expense of retrofitting BIM. So we built this entire level 1 model of the entire building. We made things like rooms, clickable elements so that we could link as-built, 2D as-built information against all of the rooms that as-built might cover, and give them access to that. Now, I don't know if you can see just in the top right there, we also, as part of the project, laser scanned a plant room where there was a particularly high level of sort of maintenance coming through. So we laser scanned that, and of course we're able to then fold that into our level 1 model. And this starts to give you that sort of building block, that basic model that you can then increase the level of detail by laser scanning and other things in a more manageable and cost-effective way. But it was all sort of made possible using that underpinning asset register, that superset of all assets that then link to the model automatically as you increase the detail. Okay, and look, finally, one of the projects that's now sort of ongoing, which is the Koerner Hospital. You might be familiar with it. It's a Melbourne-based project here. Sunshine Hospital over in St Albans have commissioned a new wing to it named after Koerner. Now, we've been brought into that project ultimately by the asset owner who's driving the change, and we're working with Lend-Lease now. And we're going to be going across the full asset lifecycle. So construction's due for handover in late 2018. It's going to be operated by Western Health. Currently, we're just about to start the O&M phase. Now, As I said before with our O&M module, you know, the thing that makes us a little bit different with O&M is the delivery, the contextual delivery of that information. And one of the things that sort of makes that possible, with the Joan Koerner, we haven't actually been past the models yet. Although we've got O&M starting, the models haven't actually come through and we haven't loaded them into our platform. So again, how do we handle the fact that, you know, we've got models that we want to link information to, but we don't actually have those models yet? And this again comes back to the information in that model, the non-graphical information. When things are identified clearly and consistently, we're able to actually configure our O&M system based on what we know is going to be in there. And then when those models are actually introduced into the system, those linkages are sort of enforced. Automatically, they become active. So on that particular project, you know, we're going to be way through O&M collecting information, you know, even before the first model appears. But magically, when those models do appear, provided that consistency in the underlying non-graphical information is there, then the linkages will all work out of the box, and you'll get that contextual O&M immediately. Final sort of point on that is, you know, that's one of the bigger projects that we're working on at the moment. But another interesting development around Flinders University is a change in attitude there on some of the smaller projects now. So what we're also starting to see is we're being commissioned to work on sort of sub $1 million projects. Flinders University are starting to say, well, look, this is great how we're capturing all this information, this digital information. You know, typically, you know, the BIM has been employed on the bigger projects. They've now sort of said, right, we're going to start to use BIM on every project that we're going to run, and we're going to start to capture that digital information and make it usable for the whole gamut of all the different projects and sizes that they work on, which for us is a bit of a significant shift in BIM, which is normally and ordinarily in the past focused on those bigger projects based on the cost justification. So look, just a couple of slides now on where we see the sort of industry, you know, where the sort of barriers to delivering BIM in FM sort of exist. So it's been an interesting 4 years, you know, even coming to conferences like this and seeing the nature of the presentations, how they've sort of changed, and the sort of starting to acknowledge the sort of bigger picture about the potential for these models. I think generally, though, there's still what we perceive as a bit of a lack of understanding of what's required for using models in FM. Generally, the focus is still on design and construction, the use of BIM in those particular fields, and not so much on FM. And the modeling requirements that we've been talking about, you know, the I in BIM, the information in BIM, establishing a more structured approach to the non-graphical information and what's actually required in there to make those models usable. I'll give you a sort of example of that. Often we're sort of people will say to us, look, what level of information do we need to put in the model? How much needs to go in there? And we actually say, look, try and make it as light as possible. What we need is some very basic stuff, some way of identifying those assets uniquely, and also understanding what their function are and preferably what their location is. Okay, now people talk, well, what about all this other stuff that is really useful operationally, you know, manufacturers, power output of equipment and so forth. We say, look, that's brilliant if that information comes to us. What we typically do is we take those models and we strip that information out, we put it into a SQL Server database, and we link it back to the elements we stripped it out against. And in that way, we're making that data usable. We're making it something that a normal user using normal software can manipulate and update and change if they decommission an asset and replace a new one. Because that information's in a database, we can start to do those things. So what we clearly need out of models, and this is what we got with the likes of NREL, was really an identifier for those assets so that we can separate them from services, and also what is that asset, and preferably where is it. And once we've got that basic information, for the other information like manufacturers' information, models, makes, serial numbers, all of that sort of stuff, we say, hey, look, just give it in a spreadsheet. The first thing we're going to do is load it in our database, and as long as we can link it based on the identifiers in the model, then we're golden. So don't load that model, you know, heavy. It's going to cost you more money, and models are a fairly inflexible mechanism for storing data. They can't handle complex data structures. SQL Server databases, enterprise-grade databases can handle that. That's what they're designed for. So when you're getting that type of information flowing through, give it to us in the most easy way possible. Don't pay all of that money to have a team of modelers putting it in a model, because the first thing we'll do is strip it out and then link it back. Excuse me. So what do we need to do to make this actually happen? Influence the design early. Again, it's lovely to hear what Alistair was saying about the approach that's been made on that Brisbane development on the waterside there. The appreciation that we've got to set these rules up early in the process. We've got to engage with the design team, got to get their buy-in. Now we find, and what we've always found, is driven by the client. It's the asset owner who's going to drive this change. It's the asset owner and the government and the part that they play, which is really going to make the way that the industry create models and deliver them, it's really going to drive that change. On a technical sort of level, defining the graphical and the non-graphical information. It needs to be done very clearly. And then that final point there, enforce it. It's great to say it, but you've absolutely got to sort of live and die. As Alistair said again with his various percentages of design reviews, it's very important that you enforce those rules that you lay down. And once we get that consistency, things like sort of predictive O&M, if I can call it that, linking based on things where we don't have models, suddenly starts to be possible. Okay, so look, my final slide here is just sort of moving on to an entirely new area, really, where BIM can play a part. And that's in lifecycle management. So this is a strategic focus for us right now. Our asset owner clients, which we've got quite a few, they all want better strategic asset management. They want to get more from less. They want to plan better. They want to avoid surprises, and they want to come to us and say, look, how can we do that? And when you've got 80% of your costs in operations, those kind of decisions are very, very important to get those right. We see BIM as playing a very important role in this. You can actually start to life cycle plan a building even before it's been built when you've got a BIM model, and you can understand the plant and equipment and the makeup of the systems within those models, within that building, even before it's built. You can start to life cycle it. As you move through construction, and the level of detail in your model increases, and so your life cycle model also increases in the level of detail and the output that it can give. And then finally, you move into operations and you start to combine all of that information through design and construction with real operational information. How much is something costing me to maintain? So the model sort of goes on. That bringing together of all of that information in a single place means that life cycling can start to happen earlier, and you can get a good idea of how much it's going to cost you to operate your building even before you sort of take ownership of it. So it's a big strategic focus for us, and one that, as I say, we see BIM as playing a very formative role in delivering that. So look, thanks everybody for listening. I hope you found some of our experiences and learnings interesting to hear. In summary, I was just saying to Shannon, how interesting it's been coming to these kind of forums over the last 4 years and hearing the subtle change in the types of presentations that are given. And I think this sort of acceptance of the bigger picture is becoming more and more prevalent. So very heartening to see that's sort of flowing through. But anyway, thank you very much for listening. And yeah, we'll be around the conference for a couple of days. So if you wanted any more information, then just come and give us a shout.
Fantastic. Thanks, Michael.
Thank you. Thank you, sir.